All right, welcome to the first session. To kick us off today, I'd like to welcome Stefan Krawczyk, Manager and Lead ML Platform Engineer at Stitch Fix. Welcome, Stefan. Stefan leads the Model Lifecycle team under Data Platform, and he's here to discuss how his team built a system dubbed the Model Envelope to enable deployment for free, meaning no code has to be written by a data scientist to deploy any Python model into production. So welcome. Please be sure to put your questions into the Q&A panel, and the speaker will answer them at the end of their talk. With that, I'm turning it over to you, Stefan. Thanks for being with us today.
Hi, my name is Stefan Krawczyk, and I'm excited today to talk to you about deployment for free, how we remove the need for our data scientists to write model deployment code at Stitch Fix. In terms of the layout of the talk, so I'm just going to briefly mention Stitch Fix, then talk about what do I mean by deployment for free. Then I'm going to talk about the mechanics of how we do it, and then kind of impact of how we set things up, and then going to talk about summary and future work at the end. So Stitch Fix is a personal styling service. The key things to note about us is that we're a very algorithmically driven company. We have a single data science department with over 145 plus data scientists, and we hire full stack data scientists. So what do we mean by that? Well, there isn't any re-implementation handoff. So we expect our data scientists to develop, iterate, and then productionize their work. This means they have end-to-end ownership on what they're doing. But they're not, engineering everything. They build on top of a data platform that provides tools and abstractions. If you're interested to know more about Stitch Fix and how we organize things, I invite you to check out these two links below. So where do I fit in? I'm a manager on the data platform team, specifically the Model Lifecycle team. I've been around the Valley for a good number of years, and I've spent the last 5 years at Stitch Fix. So deployment for free. What do I mean? So in a typical model deployment process, when you create a model, you need to write some amount of custom code to get that model into a microservice or into a batch task. We all know that there are many ways to approach writing this custom code, and then what we actually do here heavily impacts the entire kind of MLOps process. So at Stitch Fix, what do? We actually ask the data scientist to create a model and then stick it into a model envelope. Which then flows into a microservice and batch task. And once a model is in a model envelope, we actually give them a microservice or batch task for free. So that's what we mean by deployment for free. Now you might be wondering, who owns what? So the data scientists in this setup continue to be concerned with the Python model. Platform owns the model envelope and the created microservice and batch task, but then the data scientists also then kind of own the interaction with those deployed services or the batch task. The data scientists also specify some rules to actually trigger what actually gets deployed, and more on that in a bit. And here's a rhetorical question. Guess who's on call? More on that later. So in reality, for a data scientist, there's two steps to get a model to production. The first is they write a Python model, and then I use a provided API to save it into a model envelope. Now, this can be a terminal point. So they don't need to know that they want to take this model to production yet. And so we encourage data scientists to save every model that they have into a model envelope, whether it's going to production or not. Then when they know they want to take it to production, they then need to set up some rules and some configuration, depending on what they want to do, whether it's a microservice or a batch task. And then their model is in production very easily. This is all self-service. It takes them under an hour. And the point here is they don't have to write any code once the model is saved into the model envelope. To give you an example of like some of the ETL code that data scientists write to get things into an envelope, here I've kind of sketched something out. Here you have your standard code of you need to load some data, fit a logistic regression model, and then a data scientist, having done that, would save it into an envelope. We do have some required things that you need to provide. I'll dive into that into a little bit, but essentially this is the minimal amount of code a data scientist needs to write to save a model into an envelope and then get it to production. In other frameworks, typically get you to specify after saving the artifact to actually go deploy it. At Stitch Fix, we don't do that. So there is no explicit deployment trigger in ETL code. Once things are in an envelope and they want to go to production, if they want to build a microservice, we have a UI where they can provide configuration for what that service should be, and then they have to specify some rules that will kind of help determine what model should actually get deployed to that service. Again, this is self-service, very easy for them to kind of get set up with and deploy something. The end result is they get a nice kind of set of endpoints that with some Swagger UI and schema, so they can easily kind of introspect and poke at things. And again, they're in production in under an hour. If they want to deploy things as a batch task, we actually have a batch kind of workflow system, and we have a node that they would add into the workflow. Along with this node, they would kind of specify, again, the same set of rules as to what model should be kind of picked to be kind of exercised. And then they're providing the right inputs that are required to kind of exercise things. So this batch task takes care of, ensuring that the model can run on Spark or a simple Python task. We keep an inference log if people need to kind of know who's using their models. And again, they can be in production in under an hour. So what is the model envelope and kind of what are the mechanics behind it? In short, the model envelope is a container. That's the metaphor we're going for. Specifically, given a model, we take a few things about it. So one is the schema. So what are the inputs and outputs that a model needs and then outputs? What is the state of the model? So we serialize, a bunch of bytes. And then we also stick into an envelope a bunch of metadata. So like hyperparameters, metrics, tags, environment, get information, etc. And then once things are in an envelope, we can actually really start to think about models as black boxes, meaning we know the inputs, we know the outputs, and we know the environment it needs to run in. So it's very easier for them to take any given model and know how to run it in some other context. You might be thinking to yourself, wait, this feels a little similar or familiar to other things that are out there in the industry, and specifically maybe MLflow or Verta. My answer is yes and no. So this is all internal code, nothing from open source, but we did take inspiration and are a mix of functionality of MLflow, Verta, ModelDB, and TensorFlow extended. Unfortunately, this talk is too short to kind of cover everything into detail, so I'll save that for another time. In terms of typical model envelope usage, so we encourage data scientists to use the save model API right after any time they've created a model in their ETL. We also have APIs similar to, say, MLflow and Verta for saving metrics and hyperparameters, and we also have some client APIs to easily retrieve envelopes. The key thing to note is that once things are put into an envelope, they're largely immutable, except tags for curative purposes. So that way, people can kind of add tags and change them as the model lifecycle goes on, and as well as metrics. So metrics can be adjusted and amended at any time after a model envelope is created. So what does the save model API function do? Here I have a kind of flowchart depiction of it. The main points one is a function or an object or a model object needs to be provided. We need to kind of handle that, serialize it, as well as potentially infer an API specification from it. And then there are some things that are provided by the data scientists, other things are inferred like Python environment and Git. So given all that, we kind of stick it all together into giant JSON payload, send that into a registry that we have, and a data scientist can go kind of any model that's saved, anyone can go see and find all this information about it. For this talk, I'm just going to dive deeper into two things, specifically how we infer an API specification for the model and how we capture a Python environment to be able to kind of deploy it into different contexts easily. So how do we infer a model API schema? So actually, the goal here that we wanted to kind of achieve is we actually wanted to infer it from code rather than explicit specification, because code is always going to be more correct than some separate schema that someone has to keep updated. And so we do this in two ways. So they either need to provide a fully annotated Python function with using only Python primitive or typing standard types, So here I have two examples of Python functions. The first one is a good one that is fully annotated. So X and Y and the return of the function are fully specified with Python kind of primitive types. The second one doesn't. So X is a data frame. We actually don't have enough information to know what type of schema to create. Y isn't annotated, and also the function doesn't have a return type either. In the latter case, we actually the data scientists need to provide us example input. Specifically, we have two keyword parameters in the save model function: API input and API output, which is where the data scientists will actually provide us an example of what this of example data that we can infer a specification from. And so specifically, since a lot of APIs usually use pandas data frames, we then expect if a model takes in a data frame to actually get example API inputs and outputs. So under the hood, how do things work? Well, this is one of the most complex parts of our code base, but luckily we have good test coverage. We make heavy use of typing inspect module and is instanced to know what the thing being passed to us is. The output is a schema that's similar to TensorFlow extended, so specifically the data validation module. And essentially, this is a key component that underpins a lot of our ability to exercise models in different contexts, because we really need to know the exact inputs and outputs that are required. And this also enables us to do validation where required. The current limitations, though, is that we don't handle default values for Python functions, and we only expose one function per envelope, meaning so if you have a model object that has multiple functions, right now we only expose exercising one of them in an envelope. The flow diagram I kind of have here to summarize things is we either get example data or a fully annotated function. If so, we take the annotations. If not, we take the example input to kind of create a function specification. So you might be wondering, okay, so moving on to how do we create Python dependencies. So here I have this ETL code again. Notice in the save model call, there isn't any specification of what Python dependencies are required to kind of use this model. Specifically, this model requires, scikit-learn to be in the environment. It's not explicitly passed. So how do we do? So what do we do? Well, first we assume that all models or everything runs on the same base Linux environment and training production. And then we're capturing the Python version, the result of pip freeze, and the result of conda list if appropriate. For things that for Python dependencies that aren't pip installable, so you have some local Python module, we actually serialize that as part of the model, and that's how we get that into production. So how do we build the Python deployment environment? Here's the flowchart kind of depicting that. So given these raw environment values from the output of conda and pip, if we're in a conda environment, we kind of have to do some merging to get the proper final list of things. If not, we actually send things through a filter. We then add our deployment dependencies required for our deployment environment, and then that's what we've finally come up with as requirements.txt for that. You might be wondering, what is this filter step? So it's a hard-coded list of dependencies to filter. So we know that Jupyter Hub is a common dependency in training, but we definitely know we never want to have that in any production environment. So we have a list of these things to filter out. You might be wondering, is this a brittle way to do things? I want to say, actually, it hasn't been a problem. The upkeep of this list has actually been pretty cheap, since we only ever update it like maybe once or twice a quarter. So what's the impact of being on call? So remember the split before where I was talking about concerns where the data scientists are just concerned with the model and provided rules to know what to deploy. Platform is concerned with the model envelope and creating the code for the microservices and the batch tasks. And the data scientists, they're concerned. Then they take over actually exercising the batch task or the microservice. So my team is on call for the code that is auto-generated. So those of you who have been on call probably empathize with this, but I think there are two truths of being on call. One is no one wants to get paged. Especially no one wants to get paged in the middle of the night. Specifically, most people would not want to get paged for a model they didn't write, and which is the case here. My team is on call for a model that we didn't write. You might think this is actually, an anti-pattern with respect to the DevOps world of, us being on call for something we didn't write. But I want to say this actually incentivizes the platform to build out MLOps capabilities. Specifically, if we can capture bad models before they're deployed, we're not going to get paged and everyone's happier. If things do get deployed, we're incentivized to have, much better observability monitoring, so we can quickly, alert and, speed up debugging if things do happen in production, because we want to quickly point out whether it's us or the data scientists. And luckily, with the setup that we have kind of the way that we have set things up, we have the autonomy and freedom to kind of do so and figure out how do we do this in the best possible way. So what can we change? In this two-step process, there are a bunch of things that we can touch. Specifically on the API side, anything that we automatically capture and infer, we have free license to change. So the Model API specification, data scientists don't give us that. We can kind of figure out how to infer and, in turn, figure out the internal representation and change it very easily. We can, we determine dependency capture and, capturing things about the environment. So we have free license to kind of augment and adjust them. To help with things, we can, provide incentives for data scientists to additionally provide things like, the data links to data sets, metrics, capturing metrics for models, tags for curative purposes, which then can enable us or set us up better for different MLOps approaches. And specifically, we have full license since we control the deployment of models. How do we do model validation and when should we do it? How do we do model deployment and rollback? So should we do, red-black deploys, rolling deploys? Should we deploy to a staging environment first? Do we do a canary deployment, etc.? We have, free license to really determine what's best for us. We also have to control the code that, things are deployed with, since, so therefore we can actually standardize and instrument how we want everything to look. And so that can kind of map to, the different kind of logging and monitoring and alerting kind of functionalities that we may or may not have in-house. We also get to kind of choose the architecture. So do everything in microservices? Do we use something like Ray, or do we, come up with our own thing? And then lastly, we also control and own the dashboarding and UI. So if there's something that needs to be specified more and to help with, reinforcing specific behaviors, we have license to control and change it and adjust it as necessary. So the overarching benefit of this approach, I think, is that data scientists get to focus more on modeling. And so this means that there are more business wins since they're not distracted by getting things to production. And then platform gets to focus on MLOps, and in which case we actually can be a rising tide that raises all boats, since we're incentivized to do so. So in short, I'm going to summarize. So deployment for free, we enable deployment for free by capturing a very comprehensive model artifact, which we call the model envelope. This is a key cornerstone of really us understanding what a model is. And then this facilitates us to essentially auto-generate code to exercise models in any context very easily. Platform owns, the auto-generated service and batch task that I'm gonna restart this slide. Okay. Summary and future work. So what do we mean by deployment? So to summarize deployment for free, we essentially enable this by being able to kind of really capture a comprehensive artifact of what a model is, and we call this the model envelope. The model envelope then facilitates basically enabling us to auto-generate code because we know the inputs and the environment that are required to run a model in different contexts. And platform is on call for the auto-generated services and batch tasks from models saved in the model envelope. Business wins here are that the data scientists get to focus more on modeling, and platform is incentivized to improve and iterate on MLOps best practices. For future work, we have a bunch of things planned. So obviously we can do a lot more on the MLOps side of things. So how can we instrument and get better observability and scalable data capture and alerting? How do we do model validation and continuous deployment patterns? What's a good way to set that up that works for most data scientists? Or what are the different paths that or ways of doing it that we want to enable for different kind of business contexts? We have another approach that we're thinking about is called models on Rails. So since we auto-generate code for the model in production, if that model has to meet some specific SLA requirement, how can we kind of provide a guided path or rails all the way back to training to ensure that any model that's created that needs to fit into that kind of spot in the business, that will always meet that specific SLA requirement. And lastly, we're actually thinking about, how do we abstract the ETL process from the data scientists? So how do we get them to write less code? And even like in this case, how do we enable them to not even have to worry about the model envelope in the first place? So we're working on a way to provide configuration-driven model creation. And so this will abstract away a lot of the glue code required and essentially abstract away how models are trained and saved as well. Thank you. That's it for my talk. Teams hiring or platforms hiring in general, happy to take questions or hit me up on Twitter or LinkedIn. Thanks.
Thank you, Stefan. That was an excellent presentation. We have a number of questions that have come in from the audience, so let's go ahead and dive in. The first one we have is model envelope framework agnostic?
Yes, so largely any Python framework we can kind of handle and save to an envelope. So in terms of saving envelopes, yes. On the deployment side, we might have to do something special for it given the framework, but largely, yeah, it's meant to be pretty framework agnostic.
Wonderful. The next question is, how do model envelope approach comparing to a Docker approach? How does the model envelope approach compare to a Docker approach? I think is what they're trying to say.
Yeah, so it's actually, I want to say, we actually deploy on Docker containers, say our microservices. So I want to say, and our models are trained in Docker and in some sort of containers or Docker containers as well. So we actually, I think we're very complementary in that we work in any environment, so we don't have to assume too much, but we try to capture enough information such that if we do want to, if training is happening in a specific Docker container, we can link to it so that we, at build time, we know that we can reference that Docker container. We do have those hooks in there. So I want to say it's the model envelope provides a different specification from the model point of view of what's required, rather than looking at a Docker file and what's required to create things. But we can the model envelope essentially can use or be built on top of a Docker approach very easily. So we specifically designed it actually to make it easy to create a Docker container to deploy things in different contexts. Hopefully that answers your question.
I think it did. The next question with that is, what is the length of time on diminishing returns from using an off-the-shelf service as compared to building or adapting your own internal service for MLOps and data?
I mean, yeah, it's a tricky question. I think it probably depends a little on your company context. So at Stitch Fix, for instance, we have 145 plus data scientists, in which case I have a little more leverage for the things that I put out as to the impact they have on an organization. But if you're in which case, designing and adapting things for the things that we have built in-house is probably going to work better longer term for us. But if you're at a small company or a smaller team, or maybe don't have the engineering support, I think off-the-shelf things probably get you very far very quickly. And then it really depends on how your company evolves and maybe your modeling domain, where you get your data from. Do you need, streaming, or is batch okay? Like those questions start to come up and really kind of, I think, dictate whether an off-the-shelf solution versus building your own really makes sense. But yeah, there's I want to say, I'm lucky at Stitch Fix just because we have a platform team, so I get to think about and build these tools. In which case, we can make workflow integration much better than with off-the-shelf tools. But I realize a lot of people don't have a team such as this, so I think I would say I'd look at off-the-shelf tools first before trying to build something. So it's like if you're building MVP or trying to get to market, the key thing is speed. In which case, knowing what off-the-shelf can do for you first before building, I think is generally where I scare people to try or look at first. I didn't answer your question, feel free to ask it again or hit me up in Slack.
Perfect. Yeah. Just a reminder, all of our presenters are on the Slack. You can definitely engage with additional questions. We got time for one more. One challenge in a batch system is that the batch system itself has dependencies that are in conflict with model dependencies. How do you handle that?
Yeah, so we actually haven't had too many cases of this occur. So one nice thing of separating, the concern being of the data science ending at the model envelope is that as long as we can capture what the model requires, we can actually work on, say, with other platform teams to build the requisite batch environment to ensure that things work. This is where the filter step potentially helps. So can we, so given a model, if we need to, has some dependency issues, we can actually build a specific, deployment path for it. And so, in which case, like what should be filtered out from it? What specific dependencies are in conflict? So luckily, we've only had this happen once or twice, but it was just we just had to talk to the platform team to kind of figure out the actual dependencies. But would be actually interested to dive into more to hear what the actual problems whoever this question asker came up with had, just to see whether there's anything I can learn. But yeah, hopefully I answered your question. But otherwise, I guess in summary on that, we give the model envelope. We have the ability to create specific deployment paths. So if there is some esoteric model that needs something specific, we do have the flexibility to create something special for it.
Great. Well, thanks. That's been super informative. And everybody do jump over onto the Slack channel, the Slack workspace. Stefan is over there now, and he is live answering additional questions. There's a link to it in the resources section. And we'll see you over in a few minutes. Let's head on over to Mita Dash's presentation coming up next on how to manage model lifecycle with a model registry. Thanks, everybody. We'll see you soon.
Thanks, everyone.